So good afternoon, everyone. Oluwaseun Ajayi is my name. I'm a data scientist, at the same time a geologist. Interestingly, I started my data science journey here in Studies Lagos, Cohort 7, some few years back, and it's been progress after then. So that tells you that everyone here can make sense of this data science journey by kickstarting here from Studies Lagos. This is the lab session as a follow-up from last week class, where we were introduced to the world of data exploration and visualization. You remember the class was taken by Asida. And towards the end of the class, she introduced us to a mini project. I don't know if you remember. And where she discussed about data sets on Google Play Store apps and reviews. And we asking several questions and thinking of how to explore and visualize it. So in this lab session, we'll be getting our hands dirty about trying to uncover the hidden insights under the Google Play Store apps and review data sets. Want to see, in this class, we'll be acting like we are assuming we are developers. So you can add developer to the beginning of your name for this lab session. So we are assuming we are developers. We want to develop an app and put it on Google Play Store for downloads. But before doing that, we need to understand what is currently happening. We want to make sure we are not building or developing an app for that will be useless or that wouldn't be solving any problem. Or want to know what parameters or criteria we need to meet if we are developing an app to put on Google Play Store. We want to know, should we make our app free or paid? Should we, and all sorts of things. So let's go through the data set and see what it has in stock for us. So today we'll be working with some new libraries. As beginners, it is okay for us to import Python libraries when we need them, but as best practice, it makes sense to import all the libraries we'll be needing at the beginning of the notebook, so we don't do some imports at the middle or while working. So it makes sense to put all the libraries we make use. It makes sense for us to import them at the beginning of the notebook. And today we'll be making use of pandas, which I have imported as a PD. This is an alias, and it is a conventional method. Conventional alias. So whenever I need pandas, I don't need to type PD. Pandas in full again, I just use the PD and I'm good to go. I'll be using pandas for manipulation and data cleaning. We'll be using I believe we are a little bit familiar with pandas, but we'll be using some new guys like Matplotlib, Seaborn, Plotly, and these tools are useful for visualization. They have different strengths, and we'll explore the beauty of those of the libraries. And data, the source of the data is here from Kaggle. I'm sure we are familiar with Kaggle by now. I remember Ajayi introducing us to accessing data from Kaggle and the likes. So as a data scientist, data needs to excite you. Exploring data and visualizing it should be excitement to every data scientist, because that's what we live by. We live by uncovering hidden insight in data. And so let's get started. The first thing we want to do is we want to read the data sets into. You want to read the data set you'll be using, and Pandas has blessed us with a series of methods to reading different kinds of data sets. In our case, the data set we are using is a CSV file. I will be importing the first data set, which is the apps.csv data set. Now you need to check the link. You need to copy the link of the data sets. You need to know the part it is. I know where mine is. I'm working on VS Code, so here's my data set in the data set folder, and it is named apps.csv, and so I can just access it like this using data sets. I have options. I can pick this. So yeah, I'm naming the data set apps_data. So that's just the variable name. So after reading in the data sets, we want to, first thing you want to do is want to check what the content looks like. And what are the columns, what are the rows, what are the features present in the data set. And a good way to do that is use the .head method of pandas to check the first 5 rows. So when you use the .head method, it gives you the first 5 rows of the features in the data set. Okay, after reading the data set, we want to check the what the data set looks like, including the features and the rows. And so I've read in the data set and I've used the .head method to check the top 5 rows. If I need to check more than 5, maybe I want to check 10, I can pass in 10 as an argument, and I'll be able to see like 10 rows here. So that being said, I can see a number of features or columns here. To start with, I can see this unnamed column. It's like a repetition of the index here. So it's something that we want to do away with. This happens when the data is saved with an index. When we attempt loading it again with pandas reassigns an index to it and takes the former index as a new column. So that's why we have this guy here. And as we move on, we need to drop it because it's irrelevant. Also, it could be because the serial number are not progressing the right way. Maybe at some point, instead of having 6 following 7, we have 6, then we have 8. So pandas believe it is not the index and it assigns a new index to it. So we need to drop this guy because it's not informative. But I can see the apps column, the app column, which gives us the name of the app. We can see the category column, which gives us the category the app falls into. So all these apps here, you can check them on Google Play Store and you'll find the apps there. So this story should be easier in explaining. So when you go to Google Play Store and you click on an app, you get to see maybe the category the app falls into. You, as a user, you get to rate the app based on whichever property you find you deem fit. So we get to rate apps from maybe 0 to 1 to 5, and we can also rate them in decimals. The reviews column is telling us about the number of times this app has been reviewed. The size, which of course is in MB, is telling us the storage size of the app. The installs, this feature is telling us how many times the app have been downloaded or installed. Then the type is telling us if the app is a free one or paid. So whenever it is free, we see free. Whenever it's paid, we see paid. Also, the price column is going to tell us how much the app costs if it is paid, and if it is free, of course, it will be 0. Then the content rating, there's a segmentation to say, okay, this app is for everyone. It's for teenagers. It's for kids. It's for 18+ guys. So that's what the content rating should represent. Then the genre is a subsets of the category column. So where a category like art and design can have series of genres under it. Then we also have access to the dates. The app was the last date it was updated, the version and the Android version. So that being said, we can now start exploring for other things. So this is a dictionary telling us what each variable represents. You can see the application name the category belongs to, the overall rating, the size of the app, the price, and the likes. So after checking for the checking for the features or the variables in the data set, another thing we always want to know, since we now know the number of columns in the data set, we also want to know the number of rows in the data set. And we can do this by using the pandas.shape method, which is going to return a Boolean. It's going to return a tuple rather of the number of rows and columns. we can see the data set has about 9,700 rows, which is telling us we should have about 9,700 unique apps on Google Play Store and about 14 columns. I will say 13 because of this guide that we are going to drop as we move on. Another thing we want to check is the data type of each column in the data set. So in Python, I'm sure we are familiar with data types in Python. We are familiar with strings, with floats, maybe integers too. For those of us who don't know, when we have letters like this, they are denoted as strings. But in the data frame, this data type is denoted as an object. And so we are expecting the app feature or column to be an object data type. We're also expecting the category to also be an object data type. Then reviews will be integer. Size will also be floats. So installs are expected to be integers, but when you look at it, you can see we have some commas and plus there. So these special characters will hinder this install column from being integers. So a good thing we can do is during the data cleaning step, we can remove the commas and the plus, and we are going to change the data type. So currently this column should be an object because of the special characters. So we'll remove those characters and we'll change the data type to an integer as it is expected to be. And also the type should be objects, string. Then the price should also be float. Well, I've gone through the data and I can tell you that the prices have a dollar sign in front of them. And that is also another special character, which is hindering the data type from being a float as expected. So the price column is also an object. I'm talking out of the blue. So let's check the data types. So Python has provided a data type method which helps us to check. So we can just call on the data sets, which we have named apps_data. Then we can do d types. Okay, and this will give us the data types of each column in the data set. So we can see the unnamed column. You can see app is objects, category is objects, rating is float as expected, reviews is integer, size is floats. Then we have installs, which is objects like we presumed. Do we understand? Are we following? And we can also see price is objects. Makes sense. So we can see price is objects, and we also need to change the installs and price column from objects to integer and float respectively. So after checking the data types, we can also use the .info method of Python, of pandas, to explore the data. And this gives us not just the data type, but also the number of the non-null values in the data sets. Now, this takes us to another concept. Apart from checking the head of the data, we have the privilege to also check. We have the opportunity, or whichever way we want to put it, we have the luxury to also check the tail, which is the last 5 rows, or we can enter any argument to give us whichever number we are interested in. But I'll be using the default, which is 5. So we want to see the last 5 rows in the data set. Rather than checking the head, we can also check the tail. Okay, now what I want to show us here is you can see this second to the last row, and can you check under the size column? You can see a guy that looks like NaN. We call it non-values. So this is so we can have series of this kind of values across the columns and rows in the data set. These are regarded as non-values. That means for this particular cell, there's no data points, there's no real data. So we are denoting it as none, so that we can still work with that column. So that's how the data came with. For maybe the person putting the app up there does not want to give users insight in what the size look like. It's thinking, oh, if they know the size, they might run away. So I'm not telling them the size, so they just install and see how much, whatever size it is. Or I don't want to. it could even mean when they were collecting the data, they omitted that part. So this could happen due to a lot of reasons. So across the data sets, we could have a lot of non-values, and they don't look good to us. We regard them as missing values. We want to maybe replace them. We want to maybe drop them if they are misinformating. If they are going to cause some misinformation, you might want to drop them. You might want to do a backward or forward fill. I don't want to go into the depth of that because of time this afternoon, but I'm just introducing us to know that we do have missing values in data sets. And when we look at we know the data set has about 9,659 rows. And most of these columns have the same, means we have non-null. Non-null means there's a data point for such rows. So for the app column, we can see every data point in it is non-null, means we have unique apps in the entirety of the app columns. But when we get to see the rating, we can see the number drops. It means the rating has some or a number of null values. And what that means is, let's do something else. Rather than just checking the non-null values, let's check for the null values. And we can do that by just calling on the data set again, using the isNull pandas method and summing. What we are doing is throughout the entirety of the rows, wherever you see non-value, continue counting until you have a sum of everything. So we can see on the rating, we have non-values. The NAN I showed us here means there are about 1,463 non-values in the rating column. And the same thing for size, we have about 1,227 non-values. And we can also see some in the current version and Android version columns. These guys don't look good. Ideally, we want to undo these missing values. Maybe we might want to drop them or fill, like I suggested earlier. But in this lab session, we wouldn't be dealing with the non-values. We'll work with it that way and see if we can make sense of it. But in real sense, you want to undo this. Because of time, we wouldn't be handling the missing data. But I just want us to know that there's something like this exists and there's a way it is being handled. So I'll share materials to how we can deal with it later in the future. So now that we've cited the problems we have with the data sets, now we are moving to the step of cleaning the data. Okay, so now we want to start cleaning the data. I've mentioned a number of things we need to do. I mentioned that please note that at different intervals, we would always need to recheck the health of the data to see if maybe we are making changes and the changes has been implemented or it is effective. So throughout the data science, this process will be doing .head numerous times. So this is 2. Let's work with just 3. Okay, cool. So the first thing you want to do in the data cleaning step is ideally you want to keep a copy of the data. So whenever the cleaning process goes wrong, you don't need to go back to the top and reload the data. You just need to come to the copy of the data you kept somewhere and re-grab it. So what I'll be doing first is I'll be keeping a copy of the data. I'll be assigning it to another variable name so that whenever I need the data, I can just come and pick it up from here. Ideally, we might not be needing it. That's if we don't come across issues. But when we come across issues, we just come back here and we grab this copy again instead of going back to the top and reloading the data. So we can do that using the .copy method in Pandas. That being done, I mentioned that we need to drop this unnamed column because it is not informative. It is redundant. I mentioned that you can see it is like same. It is just like the index. But at some points, you can see there are some jump-ins. We can see that the numbers don't correlate, which tells us that at some points there are some the progression is not continuous. That's why Pandas read it in as a colon instead of the index. So we need to drop it. The summary of this is it is useless, and we need to drop it. We can drop a colon in Python using the .drop method. What you just need to do is you need to pass the colon name into this the drop method. If we are not sure of what the column names look like, we can just do a dot colon to check. Okay, now we are aware that Python is case sensitive and it's sensitive to the core. So a good thing to do is just copy the name exactly so that we are not passing in the wrong column name. At first, let's try to pass in. Let's take away the space to see what will happen. We can see we are getting an error saying that the colon does not exist. And that is because the column name was spelled wrongly. There's a space here. So there's need for us to grab the column name exactly the way it is so that we don't run into issues. And we are setting in place to true here so that we are bidding the unnamed column goodbye forever. If the in place is not in true, what will happen is the datasets, the colon will only drop for this output and it will remain intact in the main dataset. Let's see what that looks like. You can see that at this point, we do not have the apps data. We don't have the unnamed column again. But when we check the data set, it is still there because in place is set to false. So we can see we still have the unnamed column. So what we need to do here is make sure that we are setting in place to true so that we don't come across the data again, the role again. So we check the head of the data again, it is not there again. Does that make sense? So another thing to check after like dropping one of the columns we've cited, it's reasonable for us to check if there are duplicates in the data set. Sometimes there could be an app could be mentioned for this data set. An app could be mentioned maybe not just once, but it could be mentioned like 5 times or 2. And that does not look good. We want every app in the data set to be unique. So a good way to check for duplicates is to use the duplicated method in pandas. Something like this. We want to do the duplicated, and we want to sum it. So what this returns is it returns a boolean. We should know by now that booleans means either true or false. So yeah, we have this output. Wherever the data set is unique, where the app is unique, it tells us false. But when they are duplicates, it tells us true. And we can do some computation, like mathematical operations on booleans by trying to sum it. So this tells us that wherever we see true, it's going to add them together, and we'll be able to detect the number of duplicates we have in the data set. So if we do a dot sum, so now that we do a dot sum here, we get to see that there are 0 duplicates in the data set. And that's the same thing I'm doing here, trying to assign duplicates to a variable named duplicates and doing the dot sum, and we can see still 0. So in case, let's assume there were duplicates, we can use the drop duplicates method to drop these duplicates and we will be left with unique app features. Does that make sense? So let's move on. I mentioned earlier that we need to do some cleaning with some columns, like the install columns. In some columns, we noticed that it has some special characters like the commas and the plus. This is just me trying to see just the unnamed columns, and we can just index for just the top 5. And what this is doing is we are just saying, give me everything from the beginning to 5. So we just have 5 data points here. So we can see we have commas and we have plus, and we need to drop these guys because they are hindering the install colon from being an integer like it should be, but it's restricting it to be an object. And we want to make it an integer because we want to do some mathematical operations on this column. We want to maybe do a sum, or maybe do basically maybe sum. So a good way to do this is I'll be creating a I'll be creating a variable, a list called characters to drop, characters to remove. Let's call it characters to remove from. Then we want to pass in the characters that are present in the install colon. I can see comma. We're passing it as a list, and I can also see the plus. So we'll be using a for loop to iterate through these characters and removing them. I don't know if you're familiar with what a for loop looks like, but we can see for characters in characters to remove. Let's start by just printing the characters so we can understand what a for loop does. What we are saying here is for characters in this list, just print them. So we can see it's printing the first item, which is comma, and the next one, which is a plus. So let's assume we had more characters like the dollar sign. What's this guy? Okay, yeah. And we run this cell, we can see it's giving me the comma, the plus, then the dollar sign. So we are not interested in printing these characters, but what we want to do is we want to remove them from the install columns. And a good way to do this is we reassign the install columns. Okay, apps, let's go data. We want to create a new column, but we are calling the column the same name as the install columns. Then this column, the new column we are creating, should go to the apps data and data frame. Then it should access the install columns. And then Pandas has this apply method, which gives us the privilege to apply some functions to columns in our data frame. So what I'll be using the lambda function. What this is saying is for every x, means for every data point in the install column, replace every character with nothing. I don't know if we understand what I'm trying to do here, but let's do something first. So let's say for every character in the install columns, or for every commas, let's start by just commas. What we are trying to do is for every commas here, let's try replacing it with maybe a dash, or is this an hyphen? Let's replace it with an hyphen. Now we'll get to understand what's happening here. So now let's recheck. So what we can see is wherever we have comma, now instead of the commas, we now have this hyphen that we passed in here. Does that make sense? Okay, but what we do, we are not interested in replacing the commas with a dash, but we want to replace it with nothing so that we have a clean numerical column. So we are saying for every characters in this list, let me put back the plus. I'm saying replace the character with nothing, and that is what this guy is going to do for us. Now we recheck the column. Okay, I'm supposed to remove this guy too. When we check the column now, it's now free of the plus, the commas, and even the dash we just imputed there. Does that make sense? So after doing that, we can still see that the data type remains an object. Later on, we'll get to change the data type from an object to an integer like we want to. But we also need to clean the price column. Let's recall the column like we did for the installs. So let's index for the top 5 like we did earlier. all these are zeros, but I'm certain at some point we should come across. Let's check for the maybe 1000 to 1010. Okay, yeah, good. Now we can start to see some paid apps, and we can see there's a dollar sign in front of it here. So we want to do the same thing we did for the installs. We want to remove this dollar sign so we can have a clean float. So I want to undo this using another method instead of using the lambda function or the apply method. So instead of, I just want to show us another way to undo this. So instead of writing a bulk of code like that, we can use regular expressions by just saying wherever you see a dollar sign, or even if we have more characters, we can put them here. By just saying wherever you see dollar sign, replace it with nothing here, and that will have a column that is as clean as we want it to be. And when we recheck the price column now, we'll see that the dollar sign is gone. So this removing that we are doing, I've compiled them in a nested loop. So we have a list of the characters we want to remove. We have a list of the columns we want to clean. So we are now saying for every column in the columns to clean, that is for installs and price. And we are nesting the loop again. We're having another for loop within a for loop. We are saying for characters and characters to remove. So it's going to iterate through this list. We are saying replace all those guys with nothing, just like we've been doing earlier. Does that make sense, please? Yeah, makes sense. So I mentioned that the data types still remain what do we call it, objects. So we can, at this point, we just want to change the data types conveniently to what we want them to be. If we change the data type before we did this cleaning, we will come across errors. But with this cleaning now, we can easily change those data types to whatever I want to call it. So we want to change the data types for two columns, the installs. We want to change installs to integer installs. This is okay. We want to change installs to integer, and we also want to change the price column to float. And after doing this, we also want it to print out the data type, so we see we are doing fine. So at this point, we check the price column is no longer an object for a float, and we check installs is now an integer. So also, I did not mention this earlier, but maybe I did. We have, let's check. We have a data colon that's, okay, good. We have this colon last updated, which is giving us the dates of the last time the app was updated. And we can see this, the first app here was last updated January 7, 2018. This data type, the data type of this colon is an object, but we want it to be in date time. So we can also do some computations. So it makes sense to convert columns that contains information about dates to a date time data type. And that's what we'll be doing here using the to date time pandas method, and we are passing it the colon, and we are telling it that you should take the months, the day, and the year, and change the data type for us to what do we call it, to date time, so that we can do some work with it. And at this point, if we check for data types again, we can see that the last updated is now a date time data type. Having done that, we can now use the describe method to check the statistics of the numerical features. Remember, we now have rating, reviews, size, installs, and price as numerical features within the data sets. So now we can just do a dot describe method. And this guy is going to give us the counts, the mean, the standard deviation, the minimum, the maximum, the median, and all for this for the numerical features we have in this data set. So we can see that the mean of the rating is about 4.17. The median is about 4.3. You can see the size colon has a mean of about 20.4. You can see the maximum is about 100. So it means so this is giving us just statistical information about the data set. So we know on Google Play Store, the biggest size of an app is 100 MB. It's not bigger than that for these data sets per se. Having done that, now instead of we have all this cleaning step and loading step in different cells. Most times, it's not every time as a data scientist that you'll be working in notebooks, or we might want to reuse this data and we want to do the cleaning again. I don't want to go to every cell and start doing all the cleaning again. It makes sense to have a function that does the cleaning and that loads the data and does the cleaning. So what we are going to do is we are going to take everything we've done so far and put it in this function. For the first thing we did is scrolling is going to be a little bit. The first thing we did is we read in the data. So I can just grab this guy and come and put it in my Rango function. Do we know what a function is? Or we need me to explain? I recall we were even using util functions in the morning. So this function is going to take the data part. So what that means is instead of me having this part here, I'm going to put the data part that is the argument here, instead of putting the data part itself. After loading the data, the next thing we did is we dropped the unnamed colon. I'm not taking into consideration the head we were checking, the unnecessary things or necessary things we were doing, but we are working with the things that did add effective change to the data set. So that is what we are doing here. So we are putting everything in a function. So at once you just pass in the parts to your data set, all the cleaning process happens at once. So let's do this instead of just for clarity. Let's just assign this to same variable. And the next thing we did is we checked for duplicates, but it is not necessary. We are putting together the things that affected real change to the data set. Like the next thing we did is we attempted dropping, making sure the installs and the price column was clean. We need to index this to make sense. Like, the next thing we did is we changed the data type, and that is what we did here. You need to be sure we are picking things that really affected change. Like this data type is printing the data type is not necessary since it's not like giving us any real-time change. So we also have this. And the last thing we did was we changed the last updated colon to a date time. To a date time data type. So now we have a function that does the entirety from reading the data into making it clean like we want. What this means is I can just maybe I want to let's call the Rango function, Rango data function that we just created. Let's pass in the data parts. If I recall, it's data sets. And then okay. So if we check the head of this new data frame, what we can see is okay, we have some issues here. Where would that be? Okay. Let's see what's happening here. Could it be? Maybe. Let's do something different here. Assuming it is the name. Let's see. Couldn't be, shouldn't be. I'm assuming it is speaking. I don't want us to waste time here. Okay. Maybe it is this guy here. Let's see. Maybe it's the data part. Yes, it's the dot slash. No, still. It's not so scriptable. So let's replace that's most likely the problem. I was trying to guess. It shouldn't be. Within a function is like independent of what's happened before. Let's just say it's most likely the issue. Yeah. Is there any other? Okay. Okay, it's not. So that's not the issue. Um, let's do something else. Let's handle this the same way we did it. Let's see. Then we put the installs, yeah. Let's do the other one. That's it. Non-pi. We should resolve this together. Okay, okay, sorry. This guy should, sorry. Z, Control C, Control V. Sorry, just give me one more minute. Control V. Still shouldn't be. I'd install. Does it have non-type? Let's check. Just installs does not have non-values. I don't know. That's not an issue. Quick table.
So can we look at that error message again? Says something about subscriptive.
Yeah. Non-type objects. These are things we can check online. Let me attempt checking this online. I don't know if you can see my screen, but I'm outside the notebook now.
I think this line 27 is not properly nested. I don't know if I'm correct.
Okay. Come in, sorry. Give me a minute, please. My tabs are messed up. Sorry, I'm trying to. Okay, what were you saying? Line 27 is not properly nested. That's not the issue. Okay, let's see. What should this be? Let's try something else. Do a okay.
Wait, sorry, Sean. Can I see the code that's bringing the error?
Okay, yeah, it's interestingly something we've done before, but it's appearing not to work here. So I just want to run the function to reading to give me just the head. Yeah, makes sense. It means the data is not relevant itself. Let's see.
So I think
Is the part?
data type. No, the data type that's the issue.
You see, I've commented the entirety of all that, and I'm just like, I'm reading in I'm just like passing the pattern and telling it to give me just the head, and it's not working too. So it's the data sets. It's the data part, I guess.
Yeah, it should be the data part. It's working for me.
Okay, it's the data
okay.
part.
Yeah.
What's wrong here? Oh, let's just copy the part from here. This is going copy part. Let's see. Still funny. Okay, let me take this guy away. That's interesting. What could be the issue here? Very interesting.
Is it possible just pass dataset slash the apps.csv?
Yes.
How it works without, yeah.
This is very fun.
Ah.
Okay, I think let's do this.
That's crazy.
Still not it. Let's see. Let's see. Wow. So this is not letting us execute this. It's the data part, interestingly, and I don't know. I don't want this to delay us. But since it's working on your end, it means we can, let's see, we can move on. Interesting. So ideally, this function should work without stress. Since it's working on somebody's hand, yeah, we can move on. So what this would what this will help us with is if we have, when we need to reuse the data, we don't need to start running the cell one after the other. We can just easily use the function to read the data and we'll be fine. Does that make sense? Last week, we were asking several questions about what questions can we ask regarding the data sets? What questions do you think we can ask regarding, what insights do you think we can gain from these data sets? What questions, when it comes to mind based on your knowledge on the data, what do you think we can explore for in the data sets? So now, there are a series of questions I already put together for us to explore, and we'll be moving a little bit faster because of time. So here are questions. First question I have here is, what category has the highest share or highest number of apps in the market? So is it maybe the art and design category that has the number of apps? What we want to do is want to do a count on every app that fall in each category to know, okay, if I'll be creating or developing an app, should I put it in maybe the most popular category, or I should create something unique and put it in the least popular category so that I'll be solving a unique problem? Or these are just questions that come to mind. And there's another question here that's what category is the most downloaded? So ideally, it might not be the category that has the highest number of apps that is most downloaded. So it could, if you are to guess, what category of we have series. Okay, let's do a check on the unique categories. A good way to do that is just to call on the colon as a category and do a unique method to, you can also say unique function to check the unique categories. So I have art and design, I have auto and vehicles, I have beauty, we have productivity, we have game, we have family. I have gone through this and I know the category that is most downloaded, and it's quite interesting. So I'm trying to ask now, if you had to guess which category has the most installations, what do you think? What category do you think it will be? We also want to check, is there a relationship between the price of an app and the number of installations? Is it that people don't install? Is it that people don't download apps that are extremely expensive, or people want free apps like myself, and I speak on behalf of myself and many others. We also be asking questions like how has people installed or reviewed apps on Google Play over time, from maybe 2010 to 2018. I can tell you that the data set range as falls within that range. This data set is from like 2018, so the most recent updates stops at 2018. You also want to check the correlation between app prices and rating. You see that people look at maybe when you install an app that is about $400 and it is doing nonsense, you just go there and you rate them rubbishly, or is it that people that put huge price on their apps, they try as much as possible to do a good work so that the app is rated well. So we want to understand all this relationship. Also, we have another data set which has sentiments of user reviews. So we'll be matching that data set, and we'll also try to gain insights from that data set. So that being said, let's get started into the order of the day. So we want to attempt answering the first question, which is which category has the highest number of apps in the markets? And the markets, by markets, we are referring to Google Play Store. So just like we've done before, a good thing to do first is check the number of unique categories. The unique categories, all the categories in the data set, what are the unique categories? And like we did earlier, you do the dot category method, or you can do the indexing, just index for the colon category. It gives us basically the same thing, only that you can't do the dot method when the name has spacing, like the unnamed colon. So we can do a category, and with this unique method that we used earlier, this guy will give us every unique category in the data set. What we can do is we can just call on the variable name and see what its contents look like. So here we can see the unique categories. Now what we want to do is we want to go into each category and do a value count. We want to count the number of apps that fall in each category. So instead of doing this guy again, I can just come here, put in category. And now what we want to do is we want to do a value count. You can just say apps data, that's our data frame name, colon category. Then we want to do a value count on each value counts of each apps that fall in the category. And when we do that, this is what we see. Okay, this one is printing. We can just, we're not printing this guy again. So what we see is these are the categories, and these are the counts, the number of apps in each category. As you can see, family has the highest number of apps on Google Play Store as at 2018. We can see games follow closely. That's 957, and we can see a lot. So this is informative, but it is not it's not beautiful. That is why we visualize, because rather than just having the information, we want to make it something that people can look through and understand, non-programmers or programmers. We just want something that is appealing to the eyes. So although I mentioned that we'll be using Matplotlib, Seaborn, and Plotly for visualizations, I did not mention that we can also use Pandas. Pandas as a .plot method. Okay, so we can use pandas.plot method to actually do visuals. So let's start by using pandas, and let's see how the visuals get better when we start using sophisticated visualization tools. So we'll be using the .plot method, and we want to pass the X and Y axis. I want us to do something first. Now we have this guy that we have named, this series here, that we have named numbers, num apps in categories. If we do a dot index, what this gives us is, what this gives us is the categories. That's index gives us this guy, all the categories in the data sets. And when we do a dot values, what that gives us is the value counts. So let's try that. So if we run the cell, now we see it gives us these values, and it is arranged as it is ordered here. So what we want to give into this plots function is want to have the x-axis to be the index. That's the number, the categories, and want to pass in the values as the y-axis. So we have an histogram. Let's try doing that. I'm expecting a suggestion. Okay, yeah. We want to put a dot index here as the x-axis. I want to put a dot values as the y-axis. So we have yeah, here it comes, and values. So when we run this guy, why is it taking time? Voila. Now we are starting to see visuals and not just words. Now we can see that here's a family. It's plotting at about 1,800. We have game that follows not closely. It's about almost 1,000. But what I can see is this plot is not big enough. We can blow this plot out and make it bigger. And we can do that using this using the matplotlib. Remember, we imported matplotlib as PLT. We are using the dot figure method and we are passing in a figure size. So what we are going to do is we are going to pass in a row and column, X and Y axis, so that it will boom this figure for us. So when we run this cell with the plot figure, we have a visual that is more well spaced. So now this is more beautiful than what we're referring to. So we can see that this is better than where we are coming from. So that is a plot from Pandas, remember. Now let's attempt using Seaborn and see what the visuals will look like we did earlier. Now we are doing something, now we'll be creating a subplot. This is just so that we can access the axis and the figure. So just take the syntax as it is. Then we'll be using a bar plot. You know, this is a bar plot from Pandas, but we have to pass it explicitly here in Seaborn. Remember, we imported Seaborn as SNS. So here we are using Seaborn. I'll be passing the same X and Y axis data. So I have a number, give me, thank you. Dot index. And I have the values. So let's plot this guy. Okay. Okay, I get it. To avoid this output that are unnecessary, a good thing we can do is put a semicolon at the end of the code and all those guys will disappear. So you put a colon at the end of the last line. So which of these plots is better up to now? This is us using Seaborn, and this is us using Pandas. Pandas is it does more of manipulation and exploration of data, but we can also use it for plots. But now we are using Seaborn, which was built basically for visualizations. Which visual we say is more appealing? I remember that we can also tweak the figure size so that it's same as I'm passing 15 by 6, just like we passed here. So now we have this visual. Which do you think is better? Is it the Pandas or the Seaborn? Which is more appealing to the eyes? Now I have to explain a few things that is here. For the first thing we are passing is the figure, which represents the figure we're actually plotting, and this one will denote the axis, the axis. Then we are going to pass this into this is matplotlib here. Remember we imported it as and we are using the subplots method of matplotlib. On this second line, what we are doing here is we are tweaking the figure size, and here we are actually we are passing in the bar plot, using the bar plot method and passing in the data as expected. So there are interesting things here. So let's try taking away this line and see what it looks like, so we can see what solution that line is doing for us. So you can see the labels here are so overlapped and it's looking uninteresting. So what this part is doing is it's taking the X labels, it's taking the X label ticks and it is tweaking it, rotating it in a portion that it's appealing to the eyes. Let's say I pass in 45 degrees. We know 45 degrees is a kind of slant. Let's see what that looks like. we can see how the label ticks are slants. But this is also having some overlap. That's why we are passing a 90 degrees so that the labels are totally vertical and can be visible for us. Do we understand what that is doing? So we can see that the labels are vertical here now. Do we get what's happening here? Another thing we can do here is we can now start adding label axis. We know this axis represents the categories. We know this axis represents the number of apps. So we can start adding a label axis. So we can do that by using matplotlib. So the beauty of matplotlib is there's this integration between matplotlib and Seaborn where you can make the plot using Seaborn, then use matplotlib to add some designs, maybe increase the size, maybe add a title and axis labels. So there's this integration between Seaborn and matplotlib that helps us do our job beautifully and interestingly. So you can just use the X label method and passing whatever name you want to call it. The X label is category, as we know. Category. We also want to pass in a Y label. This will be, let's say, number of apps. We can also pass in a title. That will be plt.title. Keep that in mind. I'm giving you. So to add a title, use plt.title. Remember, I'm hammering this because it is. Let me just say it is necessary. You get to know when it's useful. So I want to add a title. I'm just grabbing it from another plot below there, so I don't rewrite all this again and waste time. So now let's replot what we have here, and let's see the change this is affecting. So we can see now that, okay, if you want to get rid of this guy here, what we can do is put a semicolon at the last line, and we'll just have the visuals as we expect it to be. So now we can see we have a plot title, which is a bar plot showing the share of apps per category. And we can see the number of apps here, and we can see the category here. Yes, so ideally, this looks beautiful, but in some sense, it could be passing some misinformation by these different colors might be telling a different story or might be confusing to whoever is viewing the visuals. So I am telling us that Plotly is actually the best to do visuals like this. For we are plotting a category variable. Plotly does the job best, in the sense that we don't really need to define the figure size. We don't need to tell it a lot of things. We don't need to tweak the x-axis tick labels. It does a lot of things automatically, and this is more appealing. And also it does not also. So let's try using Plotly. Remember we imported Plotly as px. So what we are doing here is we are assigning figure to a bar chart. Remember in Seaborn, we had to explicitly call it a bar plot. But in Plotly, what we need to just call it is a bar. And I did not mention that we can actually also make an horizontal bar here. Instead of having a vertical bar, we can have an horizontal bar. And we might need to change the sizes here by just switching maybe 15 and having 6 here, since we are tweaking the orientation. Let's see what that looks like. So now we have an horizontal bar. Does that make sense? So now using Plotly, we are going to pass in BR. The method is bar and not bar plot, unlike Seaborn. We are passing X and Y axis like we did earlier. Then now for plot title, for plot axis in Plotly, we need to use the update layout method. Our brain is heavy. The update layout method, and here we'll be passing the title, the x-axis title, and the y-axis title. I want us to take cognizance of the differences here, because The syntax are different, but it gives us the same result. Right, so let's see what Plotly has in stock for us. Yeah, voila. Now, automatically we have the categories, we have the labels, beautiful, well, with reasonable fonts. We have the image size well demonstrated, and we also have the plots having a very good orientation. Will you agree with me that Plotly does the job better? I think it does. Now let's move on into answering the second question. So we are saying in which category has the most installation? Is it game? Is it family? Is it dating? So yeah, what we want to do now is want to use the group by. What we want to do now is want to call on the categories. Want to call on each category. Want to index them by the install columns. Want to group them by. That's the right word. Then want to do a sum. So we are saying every app in this category, sum all the installations of the apps that fall in this category. Does that make sense? Let's try working the code first. Let's see if it makes more sense. So now we have apps data, and we are using the group by method of pandas. Yeah, that's why we are calling pandas the boss here for data exploration and manipulation. So there's this group by method that helps us. So we are grouping by category. We are saying, give me every category. And what you're going to give me in every category is, give me the category and tell me the installs of every app in that category. Then what you're going to do for me is you're going to sum all the installations of every app. Now, you don't need to really tell me the name of this app. Is this just if the app falls under this category, just give me the number of installs and sum them. And you can see why we have to clean the install column so that it will be useful for us. You are telling, pick every app that falls in this category and sum the installation. And it's, let's say we are dealing with a game. So let's say Subway Surfers has like 5,000 installs, and we come across again, we see, give me another game, please. We have Temple Run as 5,000. So we are just saying, I don't care about the name of the app. In as much as it is in this category for game, we will now have about 10,000 installs. The summation of Subway Surf and let's say Temple Run. So let's see what this looks like. Apologies, I should show us what the results look like. So now what we have is similar to, it's not similar per se, but what we have is, it looks like the output we got from the first question we attempted to answer. So for the art and design category, we can see that it has about, is this in billions? This is like 114 million installations. This is not like, it's not sorted. We need to, I want you to sort it based on I want it to sort in maybe ascending or descending order. So that's what this part of the code is going to do. Sorry. So once it's to be sorted in descending order, so we have the biggest on top and the so we can see if, voila, it appears that Caleb was right. The category with the highest number of installations is game, which is understandable. We all play games, right? So
everybody is playing Call of Duty.
Okay, yes. So the category with the highest number of installations is the game, followed by communication. I'm starting an application like WhatsApp Messenger will fall under communication. So we can also have an idea why communications will follow gaming closely. Again, this is informative. But of course, visuals will tell the story better, isn't it? So let's try putting this into visuals. Now I'll be using Plotly again because we've agreed that it does the job better. And for Plotly, for a bar chart, we have to pass in the data we want to work with. And the data we want to work with is this guy we just created here, the category installs. Then passing the X label and Y label. And we want to give each category different colors, or just make this plot look more beautiful for me by putting colors. So let's see what this output will look like. In Plotly, remember we have to do a fixture before we can see the outputs. Okay, you know what, let's take it out first so you can see what it's doing. No, it's okay, let's put it in ascending order. Let's set ascending to true. So this is what we have. Well, what you see here is that this is not representative of all the categories here. As first thing, I know we have more than the number of categories here, but what it's saying is categories are containing irrelevant, maybe insignificant number of installs, so I can really do away with them. But if you really want to at least show that these categories exist, but they are not present on the plot, then this color per category will be useful here. So let's re-input the guy. Let's put category. And of course, the comma should be there. And I need to set ascending to false back because this guy is going to twerk it upside down. So because it's upside down, let's change it to false. Honestly, the behavior is not really understandable, but we know how to go around it to get what we want. So now, if we do this scrolling here, we can see we have access to all the categories, but we can tell that they are not present here. The first thing you can see is the scale is quite big. We are saying 0 to 5 billion to 10 billion, and some categories can just have maybe 10,000 installs. So that's not relevant on a scale of billions. So that's why we can see it reducing so rapidly, and some we cannot even see the colors they represent. So, and this is Plotly doing just this. For Plotly, we can, don't know what's happening here. We can do some magnification and all. So now this thing is running crazy. Okay. Let's just rerun it so we have something that looks more beautiful. So again, you agree with me that Plotly is doing justice to this plot for us, and it's giving us something that looks beautiful, something that pandas wouldn't have done. Okay, yeah. There was something about data inc in the last lecture, and that is why I would prefer Plotly over what Seaborn is giving me here. But in this case, I think the coloring is relevant because it might be, might not be. I just feel this is in as much as we want to pass in an information, we can also choose to do some designing. So the coloring is not totally bad. So that being said, as a data scientist, one thing you want to check is the correlation between the numerical features. You can see that to some extent we have restrictions around numerical features when it comes to some computations. So Pandas has this method that helps us get a correlation. Let's just see. Let's see what we have. Apps data. I can do the .core correlation method, and we can limit it to numerical features. If we don't limit it, it will still give us just numerical only. And we can see what we have here. So now what we have here is a correlation of each column against each other. How do we go about this? Let's explain this after we make. So this is passing a message, but it's not really well explainable until we attempt to put it in a plot. So let's use Seaborn to plot an heat map that gives us this same detail. So I can just copy what we have here and put it here. And we'll go ahead to explain what information it is passing. And again, I want to use a matplotlib to make the size make sense for visualization. So now we have this guy here. Okay, let's reduce the font size. Let's make it maybe 9 by 7. Okay. So what we have here is an heat map showing the correlation of the numerical features against each other. We can see here we have rating, reviews, size, install, price. Those are the numerical features in the data set. And again, on the y-axis, we have the same set. So what we are doing is we are plotting these features against each other to check if they correlate. In terms of correlates, we want to see now at this first cell here, we see a correlation score of 1. That's because we are plotting rating against rating here. I don't know if you understand what that means. In this diagonal, we can see series of 1s. That's because we are plotting a column against itself. Here we can see reviews and it is correlating against reviews. Means we are just comparing, is the data set or the data set in the reviews column, does it have a relationship or a correlation between let's say price or size? But in this case, we are plotting it against itself, so it should definitely give us 1. That is the same thing that is in the rating, that is also in the rating, the same thing that is in reviews that we also have here, it's the same thing that is in size. And we can see the color legend showing us if we have 0, it is quite dark. If it is, as we are moving up, the color is becoming brighter. So when we check reviews against dating, we can see a correlation score of about 0.055. That shows that there is almost little or no correlation between the data points in the reviews and rating column. But when we check colors that are as bright as this, when we see installs against review, we see a correlation about 0.6. And this starts to look interesting because when we look at it, we can see that the number of reviews is dependent on the number of people that install the app. So if a lot of people are using it, then the number of reviews will be higher. So it means there's a correlation. Maybe the higher the number of installation, the higher the number of reviews. Do we understand what we are referring to as correlation or relationship here? Let's take it again. We have 2 columns in the data set. Let's say we have the installation and the reviews. Merely looking at it, we are suspecting a relationship. Means maybe the higher, maybe there's a trend between both columns, in the sense that if there's an app that has about 10,000 installation, maybe it should have, since 10,000 people has visited the app and have installed it, it should have about maybe 900 reviews. Let's say 100 people refuse to review. That's like saying that there's a relationship between the number of installations and reviews. Let's say we have 11,000, let's say we have 1 billion installations. We should have a review about 900 million. So you can see that there's like a trend between installation and reviews. And that is what the correlation score is telling us here, that when I go through the entirety of the installation and the reviews, I see a trend, a possible trend or relationship between the data. And let's look at this guy that's 0.18, that's following closely. In the real sense, this data is not correlating. The features do not have close correlations like that, but because in the real sense, you could see a lot of features correlating. And this is useful when we are doing modeling. We want to investigate for columns that are passing the same message. when it comes to modeling, let's say we have a data set that is telling us about the prices of houses. And we also have, and the data set has a price column, and maybe it has the size of the house. So it's telling us this house is 2-bedroom flat. This is and the price is about 70,000. So we can tell that the bigger the house, the more expensive the price. So there's like a trend between the price of the house and the size. So when you check the correlation, sometimes you could see a correlation about 0.9 or 0.8. Then you get to know these columns have something in common, and sometimes they might be passing the same message to the model. Sometimes I don't want to go there, but just to mention, there's something we call multi-collinearity. When there's a very strong correlation between two features, we might need to drop one and stick to one that we think is more important, so that they don't pass the same message into, they don't give the model too much information and it to start predicting wrongly. So this is basically what correlation looks like. So we can see we're asking some questions about prices, and we can see price does not correlate with mostly everything. This is giving us a negative correlation. That's this negative 0.021. It's not telling us that there's something the price and the rating has in common. Same thing with price and reviews, price and size, price and installs. Although this is what the correlation plot or the heat map is telling us, it might not be telling us some things in details. Now, I've gone through this data, and I know most of the apps in the data sets are free. And so we have a very little portion of the data set that is actually priced. We can quickly do a quick check to actually get the percentage. So let's say we want to check for the percentage of paid apps, and just do apps data.price. And I want to query where the price is. How do we do this? Let's just do query. A query method. Want to see where, okay, now. Wants to do where the price is equal to paid. Let's see. Okay, it's a capital P. Let's be sure. Okay, this guy here. Okay. Now you're showing me nothing. This is the head. See the ship. That's funny. Let's check for free. So what I'm trying to check for, I want to let us know here is that about 10%, just 10% of the data. That's interesting. Okay. Let's assign this to something else. Paid apps. Let's do paid. Let's do paid apps. The shape. Interesting. Let's see. Apps data. I'm trying to check for, let's see, apps data price. Let's check for the unique to see exactly what these guys look like, so that we are not querying nonsense. Oh, sorry. I'm actually dealing with the type. So what we should have here is type. So we have, remember the shape of the data is about 9,000, almost 10,000 rows, and we have just 956 having been paid. So this creates an imbalance in the sense that we have free apps that is about 8,000 and we have just paid up by 700. So when we attempt checking for the correlation, this imbalance between the percentage of free and paid apps affects these correlations. So this tells us that we shouldn't stop asking the question of does price have influence, or does it correlate to some features? Because the imbalance in the class between price and between paid and free apps is affecting what the correlation plot is telling us. I don't know if that makes sense. So having done that, let's try answering another question. The question I want to ask now is there a relationship between maybe the price of the app and the number of installations? Are people installing maybe free apps more, or they are installing or when the app is expensive, does it have low installations? This is the question we are trying to answer. And we want to pass in, want to plot a price against, now we are using a scatter plot. When you want to check relationships like this, it makes sense to use scatter plots. When you're plotting two numeric figures against each other, it makes sense to use scatter plots. Now, we know the install column is a numerical column, and it's at the same time the price. When you're passing the data will be the data frame we've been working with, apps data. So when we, another thing we are doing here is we are using this U, which would do some coloring based on content rating. We are passing the X label and Y label as we've done before, and the title. And now we are doing a legend, which is based on the EU, and we are showing the plots. Let's see what the output looks like. I'm certain it's already in. I don't know if you can see this. Okay, yeah. Can we see this? Now, what we see here is we have an installation range ranging from 0 to about 1 billion. This is quite much. So it will be compressing the data points that is falling at this edge. You can see a lot of zeros. We know quite well that we have more free apps than paid apps. Well, we call these guys outliers. Data points that appear far away from the normal distribution, it's regarded as outliers. I'm certain Sida mentioned this in the last class. So what we want to do now is, so that we can have a good view of what is happening here, let's take these guys away, because we just have maybe 2 data points and they are staying far away. Let's take them away and let's work with maybe any installation that is greater than 1 million. We want to take it out. And work with the rest. So what we'll be passing in at the data is not the entirety of the data again, but the data without outliers. So let's see what that looks like. Okay, we've not run the cell. So now we can see that the zeros that were compacted before, that were overlaying on each other, now it's spreading out because of the reduction in scale. Now we have 0 to 1 million. That means that at this point, we're having like 200,000 installations. At this point, we're having 400,000, 600,000, and here we're having 1 million. Now, what we are checking for is the relationship between installation and prices. What that tells us is at this point, we are moving this is $0, this is $50 up to about $400. And this is the number of installations. So they're saying if the price of the app is 0, how many installations do they have? So we can see that at this point, we can see apps that are free. They have about We have apps that are free, having about 1 million installations. At the same time, we have apps that are free, having as low as installations that are not really visible here. We can even say 0. So because when we checked the correlation plots, we saw that we could not find a significant correlation between the apps and installations. And we can see the same thing here because apps that are free and are paid, they are also people are installing them. Let's do something else by reducing it to even, let's say, 200,000, so that we can see what's happening at that below. So we are saying, give me only apps that have about 200,000 installations, so we can get a good view of what's happening here. So we can see this guy that is $400. Apps that are $400, they even have about 100,000 installations. Same thing with apps that are free or about $50 or let's say $25. People are installing them in the same way. So we can see the price is not really affecting that much. It's not really affecting the installation in a real sense, because I think people are looking at the contents and if this app is doing what I need to do and I have the money, I'll pay for it. And so if you want to develop your app, you shouldn't be too rigid on either to put a price on your app or not, because if you are really solving a problem that is important, people will pay for it. That's what this plot is telling us. So a good thing to also check is if you want to answer the question of how have people reviewed or installed apps on Matplotlib over time. We will be using Matplotlib purely here. I'll be using the matplotlib.plot method. We of course, will be tracking the figure size, adding labels, title, and doing a plot show. Here again, we want to do a group by. This time around, we are grouping by the last date and the last updated dates. And we also want to make sure we are picking the year. What this means is, let's just quickly do this. This is why we converted the last updated column to date time. So we can have something like this. You can see we have access to the year. We can access the months. We can also access the day. So this is the freedom, or what's a date time data type gives us the privilege to do. So here we are doing a group by, and we are summing the installations in 2021. We are restricting ourselves to just the year. We are saying in 2018, how many was the sum of all the apps that were installed in that year? And let's see the trend over time. So let's plot this and let's see what it looks like. So what we are doing here is a line plot. And when we are doing a line plot in Matplotlib, you just do the dot plot method and you have this. So you can see that Google Play Store had quite low installation until 2017 and 2018, where they had a very high, of having about 70 billion. We have, this is 7 times 10 raised power 8. This is like 70 billion. 7 times 10 raised power 10 is like about 70 billion installation in just 2018. Unlike when we have something that's so low here in 2017. And what I mentioned about outliers, this data point is far from others. So it's hindering us from seeing what this trend literally look like. So let's do something. Let's remove 2018 and deal with from 2010 to 2017. Yeah, and a good way to do this is just index. We are going to remove the last. What do we call it? The last data points in both the X and Y axis. And let's see the output. I'm not really taking my time to explain the depth of the code because of time. So now we have removed 2018, but now we can see there's actually a trend. 2017 is not as low as we thought. It's about 3 billion installations. For 2018, it was so high, they went about to 70 billion installations. So Google Play Store as an app has experienced growth over time. And that's what this plot is telling us. One thing I want to show us is when we use Matplotlib, we can see this plot is not totally beautiful. What we can do is we can use Seaborn even within matplotlib. So I can do matplotlib, which is PLT, the style that use. So there are a series of styles we can use. You can just convert this. So we are just trying to change what the plot should look like. And this time around, when we replot this guy, see a more beautiful plot. So this is it. So what we did here is we converted. We are saying anytime I call matplotlib, give me Seaborn lookalike. So, and that is what this guy is giving for us. So we can see that this plot is more beautiful. So in case you don't want to use Seaborn, you want to stick to matplotlib or use Seaborn style, you can just use that command. And you can use different kind of plots. You can use ggplots. ggplots is what the R guys use, and they used to do Shakara for Python users. But yeah, we can also access them in matplotlib. You can see this is a better plot. This is what ggplot. ggplot is another visualization tool, and this is what it would. This is how it will look like. It's just tweaking the beauty to make it make sense. Another thing is we can just go back to the default in case you don't like what these guys are looking like, and just go back to default and you get what we had earlier. You can see that we have what we had earlier. So moving on. We also want to check correlation between the prices and the rating. Do people rate apps that are expensive well? Do they rate apps that are free? Do they give them unnecessary ratings that are questionable? So we'll be using a peer plot here. And what a peer plot does is it does something similar to the heat map. So it does a correlation plot. If we have we'll be using a peer plot. It does something like a correlation, something like what we saw when we were working with the heat map. Let's do the plotting and let's explain the visualizations. We can just go back on our own because our time is fast spent and check the syntax. But here we are doing seaborn.peerplot. We are passing the data frame and passing the columns that we want to check the correlation against each other. We are doing a U based on category, and this is we are seeing that we are interested in the kernel density estimation plots, and this gives us this tells us the distribution of the what do I call it, the categories or features that we are passing in. This is taking time. Okay, yeah. Now we have this. This is too big and we can't see everything at once. I don't know if you can track the size. We cannot. I don't know how much you can see, but what we can see is you can see price rating here, and if we come down, we see price and rating here, just almost the same way we saw it as an heat map. But what we now see here is we don't really see the correlation numbers like we were seeing before, but now we can see it. We can see like a distribution. Now we can see for the prices, most of them were this is price against price. It's just telling us the distribution of the prices. We had a lot of zeros and we had it ranging from 0 to 400. Same way for rating against rating. This tells us that most apps were rated from about, this is 3 to 4 points, something. So this is just, and there's a U on what do we call it, categories. So the colors are kind of representing each category. So we can see this light blue is representing the light blue here, maybe family, or let's say, as we are saying, game has quite high ratings. But we'll go back and investigate this later. Checking this price against rating plots, what we have here is same thing as what we have here. It's just the orientation. One is kind of horizontal, and one is kind of this is kind of horizontal and this kind of vertical. So we just have they're just tracking the X and Y axis. And this, what we can see is there's no significant relationship. Regardless of the price, people are giving their rating. The only thing we can see here is that the price apps that are quite expensive, up to $400, people don't really give them negative rating. This is rating from like 1 to 5. This is the price from 0 to 400. So we can see that though we had about like 700 apps that were paid, they did not get rating less than 3, and just one is on 3. Most of them really range from about 3.5 to 4 points, whatever it is. So we can see that if you are putting if you are building your app and you're putting a good price on it, it definitely means you are putting in the work for it to get reasonable ratings. That being said, let's try to move on so we don't spend too much time. This is us trying to check the distribution of app ratings, and we are doing this using Plotly. So let's we're going to pass in the data, which would be the apps data we've been working with all this while, and we want to plot the rating. That's basically what we want to do, and let's do the plots. It's already okay. There's apps data. Sorry, we are working with this apps data. I'm certain that if we go back to this notebook, we will understand a number of things. So just like we saw here, where we saw a kernel density KDE plots, this is now an histogram, which helps us see maybe this thing more clearly. I remember Asida mentioned something about positive and negative skewness, or is it right or left skewed? So this rating is is left skewed. This is negative skewness. I don't know why when something is left skewed, it means that it has a long tail to the left, and it has the data sets concentrating more on the right. So instead of it to be a normal distribution that goes something like, I don't know if you can see my app, now we have it tilting to the right, and it is called negative skewness. What this tells us is that we have people did not really rate apps very low. So we had a lot of apps getting a rating of ranging from about 3 to 5, especially at this 4 to 4.5 points. We had a concentration of rating. Another thing we can do is we can do a dot plot or a dotted line plot on this to show the mean, and that is what this portion of the code is doing. If I uncomment this, you can see something more clearly. So what it's doing is going to add a line plot, but it's going to make it dotted. So this is, we calculated the mean here to be 4.17. I'm sure you've seen that when we did the describe method to check the statistics of the data. We can see this is the mean of the data. We check for the median for what do we call it, for negatively skewed distribution. The median is greater than the mean. So we check the median here is around 4.3, but we have the mean in about 4.17. So what's happening here is that the distribution, what we intend to check, we get to know that it is is negatively skewed, and it's telling us that we have a lot of positive reviews. That's what we have basically. Then we can go ahead to we have another data set like we know since the beginning. There's a user review data set. We'll be trying to make use of that now. Data sets. I hope we don't have the part issues that we had before. Data sets. Yeah, user reviews. So let's do a quick head of this guy to see what the contents of the data sets look like. Review head. Can see we have the app name, we have reviews, we have the sentiments. So what they do is, when they say they like the app, it's a positive sentiment. If people are saying your app is bullshit, then it will give us a negative sentiment. And that sentiment is we get a probability, and that's what the sentiment polarity is telling us, and the sentiment subjectivity also gives us information about that. So what we are going to do here is we are going to merge the reviews data frame. We are going to merge it with the apps data, so that we are going to do that on my apps. On the app column, I'm sure we remember this from the relational database class. And so when we do a merge, we can just do a dot head to see what this merge look like. What we now have is a data frame that is that now contains the sentiments, the sentiment polarity, and that's now something we can work with. Now, the question we are attempting to answer here now is how does sentiment of user reviews varies across categories? Now we can just do, after we merged, we'll do a group by UI category. And the same way we've been doing is since we are working on sentiment polarity, we can't really work on the sentiment column because it's not It's categorical, but this is a numerical. It's like a probability, or did I say it is a density of the sentiment. So what we want to do now is want to get the mean of the sentiment polarity of each category, and we want to plot them. And this again, we are using plotly here because we said it's best for categorical variable plotting. And here we can see that the comics have the most positive reviews, followed by events. And we can see, though games has the most installation, that's the most negative installation, negative reviews. What we can see is the range of, this is average sentiment polarity, and these are the categories. So what we can see is that games has the highest installation, but it has a lot of negative reviews. Does that make sense? All right. Lastly, what we want to do is this, like the last question. How does the size of app vary by category? Want to know if I'm building an app for games, what should be the size ratio I should be looking into? Computer programmers, they take this seriously. They want to do some a lot of computations. They want to work with their data structures. They want to make sure that they are not putting unnecessary storage size on the apps they are developing, so that it will be presentable and it will also be effective. So we want to know if you are building an app suiting any category, what size is reasonable to work on? What should be your target size? Do you get? So what we'll be using here is a box plot. I'll be using Seaborn for this. We want to do a box plot on each category based on size. And so we are using Seaborn box plots. We are plotting category against size, and we're checking a lot of things here, trying to do the figure size, putting the labels, and of course we are doing the X sticks to be 90 degrees like we've always done. Now, what we can see from this visualization is that you can see that the games have, this is a box plot. I'm sure we saw that in the quiz we just concluded. This is a box plot that shows us from year to year. This is like the Q, this Q1 and this Q3, and this is the median. So what we see here is that this is the interquartile range of each of the sizes in each category, in this category. So what you want to do is, if you are building a gaming app, it should range from about 20 MB to 60 MB. Anything outside of that is an outlier, and people might not be engaging your app because it is too heavy. Do you get that? Does that make sense? This is just us attempting to tell stories or understand the insights that exists within the Google Play Store datasets. We've tried to answer some questions, but we can't answer them all because of time. And so I have put the remaining questions here for us to try. Go through the notebook, watch the video again, and try to see if you can answer some of these questions ourselves. Try to see what's a pair plot, what's an heat map, what's a line plot, what's a box plot, what it looks like. This is an introductory class where we are introducing to the world of data exploration and visualization, and we can go further and start exploring and start attempting to do more beautiful things. As data scientists, when it comes to data visualization and exploration, we become storytellers. We are trying to tell the story the data is passing across to us. So these are questions I want us to attempt by ourselves while also reviewing. I knew I've passed in a lot of things. It's just this afternoon, and it's okay not to understand everything on the go. It's okay to go and review and watch the videos and try and tweak the codes to understand exactly what it's doing, and that would help us understand the concepts better. So I've included some materials here. Although we are limited to Plotly, Seaborn and Matplotlib, and maybe Pandas, there are also other visualization tools within Python, like Olovis. Olovis has a lot of libraries even within it. We have Panel and all. You can go and check it. Oloviews too. We can check Dash, which is used to do like interactive web dashboard. This Streamlits. These are Python libraries too. And for non-Python libraries, we can use Tableau, which is used for dashboards, Power BI, and even Microsoft Excel is useful for data visualizations. I hope I've been able to pass an information. We've been able to grab one or two things in this class. And you will notice that we are doing some group by, we are doing some sort value counts. Now, I want us to make use of this Python data science handbook. We get to see a lot of more pandas methods that we can use whenever we are in need to do some computations or do some indexing and all. You could, I don't know if you noticed, I was using query to index for some portion of the data. We could also use the lock method. We could use iLock. If we go through this with this book, it will beautifully introduce us to the concepts of data manipulation, exploration, and visualization, and even a part of machine learning. So it's a very important, it's a very useful resource, and I would like us to look into it. And this will be the end of the class. I think I've been able to pass the information required. I've been able to do a little bit of justice to data visualization and exploration.